World markets are changing fast. Global competition is intense. Companies need to boost service and cut costs, streamline their organizations. People are more mobile than ever. They need access to information anytime, anywhere. Technology can help. MIPS on the desktop cost a fraction of what they do on the mainframe, and everyone is talking about client-server computing. But how can you adapt today's information systems to the changing structures, needs, and methods of business? How can you capitalize on the compelling economics of desktop computing and client-server systems? In this seminar, you'll see how British Petroleum streamlined its organization and built a corresponding client-server system. How Northwest Airlines dispatchers run the air carrier's operations through a single integrated workstation. You'll see how Aldis Corporation delivers client-server applications in 90 days and builds systems that grow with the company. And how Apple Computer's own IS department created a flexible architecture to make better use of its existing systems. Hi, I'm Russ Christoff, and I'll be your host for this Apple Seminar for One, Designing Client-Server Systems. To begin, here's Michael Spindler, President of Apple, to discuss Apple's view of client-server systems.
Apple has always attempted to bring out technologies that are easy to use. And this remains our objective and our major differentiation in the world of client-server. We apply technology in a way that hides complexity so that you can build systems that fit in first into your environment, and then just as importantly, enables you to deliver tools that people can use naturally without having to think about the tools themselves. Client-server is many things to many people, and most of the time this definition is very narrow. At Apple, we view client-server computing much more broadly. We believe that it must embrace a wide range of platforms. The ideal client can be anything from a high-end workstation to a notebook computer or even a device you carry in your shirt pocket. People in business and learning are increasingly mobile. They take their jobs with them. They should be able to take their tools with them and have the same sort of access to information they have at their desks. We believe that client-server architectures also embrace a wide range of tasks: terminal emulation, front ends, transaction processing, peer-to-peer connection, and so on. All of these provide opportunities for improving the way you do business. Any company today should be able to use any of all these technologies to their competitive advantage. And we will support all of these variations on the client-server theme. We'll promote both the client and server hardware and systems technology that will operate on your existing network. In this seminar, we will show you how several companies are building client-server systems to fundamentally change their businesses. And changing the business paradigm is a key ingredient in designing systems architectures. These companies found themselves facing daring challenges. They needed to be able to respond much more quickly to the change in business, to cut costs and become much more competitive. They needed to improve communications and get people to work together much more effectively. Technology alone isn't the answer to every problem. The people and companies you will hear from in this seminar believe that a key role in changing their companies is to help understand and reform the way business gets done. Success is not only measured by how many lines of codes they write or whether the department meets its budget. It's measured by how they can create value and turn new knowledge into a competitive weapon. They believe client-server is one of the tools that can transform the way their businesses work. They have adapted the production system and existing business platforms, the legacy of their old ways, to this new architecture. And now they deliver new services and information quickly and more cost-effectively. You will see some of their systems in this seminar, and they will tell you what the impact is these changes already have had. But we know that there is a bigger question that everyone struggles with. Client-server sounds like a good idea, but how do we get from where we are today to where we want to be? You can't simply toss out production systems that keep a company running just because a new technology paradigm comes along. And you can't shut them down while you're rebuilding a new architecture. So how can you evolve your system gradually? We hope this seminar will give you some insights into how others are doing this and how Apple can help you improve your existing systems and deliver new applications to help your company meet its changing business needs.
Now let's visit one of the world's largest energy companies, British Petroleum. To support a major corporate restructuring, BP needed to build a new information system that would be used by virtually everyone at their London headquarters. Because people who had never used computers before would now depend on them to communicate and do their jobs, the company decided to model its system on the simple telephone. Everyone has one, everybody knows how to use it, and they're all connected. Making computers as pervasive, as easy to use, and as well connected as the telephone was imperative to make the new downsized headquarters staff an effective team. In this segment, you'll learn how BP reorganized, how it geared information systems to the new structure, what it took to build client-server applications, how users accepted the new system, and how it helped BP meet its goals.
The major challenges affecting BP today are, one, really the increase in the rate of change of the business world and in the world itself. The second is one of increased globalization and with it increased competition. There was also a need, I think, to redesign the corporate center, which perhaps in the new environment had become much too top-heavy. And technology was going to be fundamental to this. It was going to support our increased emphasis on teamworking. It was going to support our increased emphasis on networking. We were planning to move, and did move, to a new building. And so therefore we had an excellent opportunity to change the technology at the same time.
Project 1990's aims were to radically change the way in which the corporate centre operated. The old, large, hierarchical department structure was washed away and replaced by small, functional teams who could then network with one another throughout the corporate centre. We have 3 different levels of information sharing. We have your own hard disk, we have the team server, and we have what we call the corporate server. All of that is done using Apple's file sharing technology. We've laid Ethernet to every single machine in this building, and indeed down in the basement of this building we have 4 VAX mainframes which run, for example, the electronic mail system. Users can go to printers in Brussels, to printers in Singapore. They can log on to any server in this building, or in Brussels, or in Singapore. There's a modem bank that we use to dial out to a series of external applications. The applications ranged from the standard client-server applications, such as the human resources application and the group companies application, through to front-ending of several large mainframe applications that were developed some while ago, before the Britannic House IT project started. For example, the diary system and also the email system. The tools we used to achieve this ranged depending on what the type of application was. DAO, Apple's data access language, was used to glue the client and the server together, and the server was provided by DEC's RDB package. For the front ending, we used a product called CommsTalk, which gave us the ability to suck information up from a terminal window, reformat it and present it into HyperCard. So again, it was glue between the server, the application, and the client. The front-ending approach was very important because that gave us the ability to retain the investment we had in our corporate email service, in our group accounts package, to quote two examples. And with relatively little time, we were able to develop front ends, develop button sets, which then enhanced the functionality of the applications and also increased the productivity of the users. People could have a word processor, they could have a spreadsheet open locally on their own machine, they could have a couple of mainframe applications open, one on a VAX, one on an IBM, and all of that is entirely seamless to the end user.
Quite a lot of people hadn't used a computer at all before. Some people just had dumb terminals and therefore hadn't been used to personal computer facilities. And there were other people who were what I'd call power users. The different systems just appear as icons on the desktop. So all a user has to do is click on the icon that he or she wants without having to remember some complicated command to get into a different mainframe system. And because it works basically the same way, it's very much quicker for people to learn. Each team has its own file server. The use of the team server is very important for teams sharing information and being able to work on documents together. And the fact that we can store documents on a common server for the whole of the corporate centre makes information sharing very much easier. We can certainly see teams who weren't using computers before getting a lot more productive.
I think the system that we put in has changed the way employees work. I think they have progressively recognised the potential of the technology, not only for team working, but also for wider working, because there's a much freer exchange of information. It's enabled them to make a much more greater personal impact, I think, through providing a lever to their abilities. Macintosh, for the company, has, I think, enabled us to implement, certainly in the corporate centre, the change of behaviours, the change of organisation, which was necessary, I think, to make an effective, a cost-effective and efficient corporate centre.
I would expect the industry to move towards a model where the desktop plays a far, far more important part than it has done in the past. So in that aspect, in a client-server environment, the client is much, much more important than the server. And it's important that all systems development and the entire IT department recognise that it's that one box that people are looking at, and the system should concentrate around the use of that Macintosh. Develop your systems around the user, not around the underlying IT architecture.
You saw how BP provides a consistent user view of all the systems, old and new, on their network. BP has made services, information, and tools from many sources readily available to the user. Like BP, Northwest Airlines has seen a lot of changes, growing dramatically in recent years, partly through mergers and acquisitions. In the process, they inherited several operational facilities, along with the computer systems that supported them, which raised an interesting problem: how to coordinate these far-flung activities to run the airline more efficiently. As you're about to see, they began by analyzing the way these groups worked together and consolidated critical activities in one location. Then, they came up with the specifications for a client-server system to improve efficiency and communication. A key requirement was that every workstation must be able to integrate information from all their various mainframes, the FAA, and other sources outside and inside the company. Color imaging, fast implementation, low cost, and an easy-to-use graphical interface were also required. Northwest decided that Apple was the only vendor that could meet all these specs, and the client-server system they built lets them add new capabilities easily as they're developed. In this part of the seminar, Northwest executives will tell you how they did it and what it's all meant to their business.
Northwest is the fourth largest airline in the world, and our mission is to become the world's most preferred airline with the best people, each committed to exceeding the customer's expectations every day. One of the ways in which we intend to do that, which I personally get involved with in operations, is by being the most on-time airline. And we achieved that in 1991, and we intend to stay at the top of the heap as the #1 on-time airline in the United States.
Well, Northwest had a special problem that we needed to address because the people who run the airline on a daily basis and try to make optimal decisions for how to keep it running on time with the fewest number of cancellations safely were spread out in 3 different buildings.
Northwest analyzed their procedures and ultimately decided to build a new systems operations control center in Minneapolis to bring together 14 different operational departments.
So we used functional business modeling to sit down and look at our business processes and how they were shared and they flowed between departments in the company, between technical operations, which is our maintenance group, or ground operations, which puts the passengers on the aircraft.
Against that model, we can then apply the how it's done, where it's done, in which system it's done, and look at where we have opportunities for improvement. The executives are then able to put those opportunities in perspective relative to other opportunities for improvement, and the SOC was obviously necessary. Northwest Airlines, through mergers of various other airlines, has created a diverse mainframe platform. Our mainframe systems run on Prime, IBM, and Unisys platforms. Flight planning, crew scheduling, meteorology, reservation systems, maintenance and control. It's all running in mainframe systems.
These dispatchers had to go in and out of 4 different systems, literally logging on, logging off, logging into the second one, logging off, etc., in order to do one flight release. What we were able to accomplish with Macintosh was to put all those systems online in a window format and have those instantaneously available without logging on and logging off.
The client-server environment with Apple allows us to present data from each of those systems to the user on a single platform.
We selected the Macintosh over the other machines because it was the one machine we felt could give us the connectivity to all our mainframe systems. It gave us flexibility to satisfy many different kinds of users. It gave us the graphics. It gave us the HyperCard application that allows us to quickly do masks and front-end changes to be more user-friendly. With all these things under consideration and the evaluation of the cost-benefit of this machine versus others, Macintosh beat out its competitors.
We were on dumb terminals before, so when we were in WorldFlight, we were in WorldFlight, and that was the only screen we had. Right now, I've got a small window into an IBM system. I've got 3 windows open into the Unisys system, 2 of which are actually tied into WorldFlight, which is our flight planning system, our primary system. I've also got a window open to our backup flight planning system should something happen to WorldFlight.
These workstations have given us the flexibility to control security and quickly configure the machines to support the individual. So if a dispatcher goes and signs in on an extra position, they know he's a dispatcher, not an assistant. It remembers the individual's personal choice on layout of the screens and the color combinations or whatever they logged out with.
The Mac has given us more capabilities to do our job, to get the airplanes from point A to point B safely, smoothly, and as much on time as possible.
Something else that the workstation environment allows us to do is break down projects into much smaller pieces. My management philosophy is that the smaller it is, the easier it is to manage.
Northwest's system is built around a HyperCard window that provides users with point-and-click access to mainframe sessions, productivity tools, and custom applications built in C, C++, Mac App, Pascal, and Fourth Dimension. It's appropriately named Navigator.
Now, the Navigator provides a launch pad for applications that we haven't yet developed. We can add buttons to it. We can change the functionality of the tool behind the button once it's pressed without affecting anything else. We don't have to change anything more than the application we're developing and the Navigator itself. One of the fun tools that we've found is QuickTime. This allows us to animate images, whether it's a video image or anything else. We've found a use for it in the animation of weather images. And so by recording or keeping a record of the past static images, we can create a cartoon, if you like. One project in particular which is going to be very valuable is called Aircraft Situation Display. What that allows us to do is take the position of an aircraft, visually represent it on top of weather images.
You can see a lot better, have a better picture of where you can route your airplanes to get around the thunderstorms.
That saves us fuel, it saves wear and tear on the aircraft, and it also gives the customer a more comfortable ride. The way in which the tools we've given the users improves communications is through significantly increasing the speed at which they can gather and assimilate the data that they need. We have also accelerated the capability to update the various systems out there. Through a single transaction, the user can now tell 4 or 5 systems that he's making this decision, as opposed to having to previously enter that data to 4 or 5 different keyboards.
Northwest happened to be one that was pretty far back in the development of computer technology in the airline business. We think we've actually leapfrogged our competitors. And we think we developed this technology at far less cost than some of our competitors did. Maybe at a cost of 20 cents on the dollar to what some of our competitors are doing on some of their mainframes. And that's one of the reasons why we will move from number 4 to number 1. We've sped up the process of communication so much that we consider the Operations Control Center and what we've done technology-wise there as one of the key reasons why we did become the number 1 on-time airline in '91, and we see it as the avenue for staying number 1 as we go forward.
Northwest has jumped ahead of the competition with the help of a money-saving client-server system. It made new applications easier and cheaper to build, and it tied in with existing systems that were built over the years on a traditional mainframe-centered architecture. Now, let's see another approach. Aldus Corporation has decided to gradually evolve its entire IS architecture. They're viewing every application as client-server, and the network and all the devices on it as parts of a single virtual computer. It's a radical vision, but following a carefully thought-out plan, they're building it today. In fact, their standardized application development procedure calls for delivering parts of the new architecture with each new application. So let's visit Aldus, where you'll hear the company's perspective on the value of client-server, where a consistent application development methodology guides each project and emphasizes return on investment. You'll see the company's first client-server application and hear about their plans for the future. You'll hear why they think it's important to have a vision of where they're going and a plan for how to get there. And they'll tell you why they think they're on the right track.
Aldus is a personal computer software company, been in business since 1984. Our customers recognize us as the leader in the area of page layout as well as graphics presentation, both on the Macintosh as well as on the Windows environment.
Macintosh is the key tool for us. We support other clients because the reality is that our business is made up of supporting Macs and PCs, but we have been involved with Macintosh since the start. It was the tool that let us do client-server in the early days when there was nothing else. And it is still the tool of choice, and it's allowed us to do things that we just couldn't have done in any other environment.
The Macintosh is suited for client-server development. our client-server applications because it seamlessly integrates with the network.
The network is handled in one place. I don't have to support all the cards. I don't have to support all the different drivers. All of the network protocols come through the AppleTalk Manager. For a machine on a network, the Mac is it.
Client-server is the most misused phrase, I believe, in the language of technology journals today. Because what it really means is, how do I marry the applications and capabilities that sit on the desktop to information and transactions that sit in the computer room or on a server on the network? My philosophy is, and our philosophy is, that client-server can be anything from decision support to order processing to manufacturing to general ledger to whatever you want to do. And in fact, what we've done is we look at every application as being what traditionally is called in the industry right now as client-server. That is, being able to have a front-end cooperatively compute with a back-end and separate those transactions to where they should reside most logically.
If you've got a flexible environment for developing applications to take advantage of how the business processes are changing or evolving, then that's the only thing you need to change. And the part that's stable remains stable.
Traditional information systems delivery, we spend 90% of our time engineering the transactions inside the processor. The reality is that purchasable technology has done that for us today. Database systems, operating systems, transaction processing monitors have made this stuff something we don't need to concentrate a lot of time on anymore. Where we need to concentrate our time, where you're going to get the bang for the buck, is understanding that business process and making that front-end model and that front-end application look like what the user expects. Phoenix is our systems development methodology. It is client-server, iterative, rapid development. It is a methodology that helps us build application software to support the business processes.
Developing client-server applications is not unlike developing other types of applications. Having a structured method for developing software applications is really key.
I believe the major responsibility of information systems is to be the process re-engineer for a company. Why is that important? Because process is the thing that's going to give you the return on investment. It is not technology. The model under which we work is we identify a customer need, we identify the process to support that need, we re-engineer that process if it's not working to support that need, then we do a cost-benefit analysis if we need to build a system, and the cost-benefit analysis is based on a 3-to-1 return on investment for cost reduction and a 2-to-1 return on investment for revenue generation. And the model is that we will deliver this capability in no more than 90 days, 18 weeks, and we will be able to measure the return in the first 12 months after the technology is implemented into production. One of the processes that was not working for the company was order processing, and specifically very complex orders that were coming from some of our largest customers. And the reason the process wasn't working is because it was relatively complex because it went through multiple screens and had to deal with multiple data files that sat on a central system. And then there was ancillary information that had to come off of some hard copy and some other database that sat on Macintoshes in fourth dimension.
So we used HyperCard to automate a lot of those functions, provide many of the decision support tools necessary for these people, and eliminated a lot of the manual steps that they had to go through.
We decided not to write host code because the package we were using was written in the 70s and it had a lot of spaghetti code, and that was just a can of worms to jump in there and try and integrate them on the back end. So we knew once it got to the terminal side of things, we could trap the data and coordinate the activities. So we built the purchase order system. We tied to the prime over asynchronous lines with a terminal emulation package running in the background. The application would actually operate these applications on the back end without the user seeing this. All the user saw was this graphical front end, and it doubled the orders that could be placed in the same amount of time and moved our backlog to 2 days.
That, again, I believe, is the way that every company should look at implementing client server. Enable the front end of a back end transaction and don't rip out the old and assume you got to re-engineer everything in order to make this stuff work.
Each development project moves Aldus closer to a future architecture that lets systems evolve along with the company. Eventually, that architecture will reduce maintenance and extend the life of applications. Today, it is part plan and part vision, but Aldus is gradually designing it into their production systems. The architecture is called Blacksmith.
Originally, Blacksmith came about because we were starting a new client-server development project, and we knew we had two approaches. We could either go in and hard code that application and essentially produce a one-off, or we could start building a foundation for ongoing client-server development.
Blacksmith today is defined as a systems development architecture for building what we call real-time cooperative computing applications. So users can sit down on a graphical screen, model their process, it automatically goes out to an object library, picks up the object function components, and connects to the data resources in order to deliver that capability to the user as quickly as possible, and they are in total control.
The principal component, I think, is a modeling environment, very much like a case tool or an entity relationship diagrammer, that would allow a novice or a local expert in a user group to sit down and graphically produce an image that represents the type of work that they're trying to do or the problem that they're trying to solve. Eventually, we expect Blacksmith to be aware of the corporate data model. And so if I am trying to produce a particular application, there will be expert systems help available to let me know what data sources are available.
As Aldus's IS group builds applications, they're also developing pieces of the evolving Blacksmith architecture.
Our next effort was Ant Farm, which is a defect tracking database for engineering and software quality assurance group. And this was the first application written in C using the Blacksmith architecture. Our next effort is a system called Navigator, and it's designed to allow our tech support people access to an information base. It's a diagnostic tool so that when they're on the phone, they can rapidly get the answer to customer questions and improve customer service.
We're building this thing iteratively. We started it with Ant Farm, which will be a production application. Navigator, which is our next one, we're going to improve it a little bit more, and that's going to be a production application. And then finally, our third iteration is where we're going to probably be building Blacksmith proper. And this will not be the final version of Blacksmith, but it'll be the groundwork.
We believe that the vision is the critical determinant of whether you're going to be successful or not successful. And what we've done is our entire organization has a common vision for what we are trying to accomplish. And I'm not here to tell you that we have achieved totally that vision, but we're all heading toward it. We all know what we want to do. We all know what our role is in delivering that vision to the company.
And that's where the Blacksmith vision is useful to us today, is this idea of, okay, this is where we want to be, how do we get there with today's technology and the problems that we have to solve today? I've explained this to the people in the Navigator project, and they think that's great because they see that as benefiting them down the road. So they're actually pretty open to the concept of using their time to develop this tool.
Okay, are the users ready for this? When you lay the concept out to a user, they get really excited. What do users care about? Getting an information. Users don't care how you do it. As long as you can do it, and as long as it doesn't take a lot of effort on their part, they're happy. I say absolutely, they're ready for it. The best measure of success that I have is that a year ago, Aldus put together a task force to identify whether innovation was going on at Aldus, and at the top of the list was Aldus Information Systems. To me, what that said is that we have confidence that you guys are doing the right stuff, and you are innovative in your approach to delivering information systems.
A few years ago, Apple Computer faced a common corporate dilemma. Like most other large corporations, Apple relied on a myriad of systems running on IBM, Digital, Tandem, and other hosts. The company's needs were quickly expanding, but these systems weren't flexible enough to keep up. Here's how Debbie Coleman, Apple's Vice President for Information Systems and Technology, described the situation at a recent conference.
So, as Apple's Executive for Information Systems, I may face a single desktop platform in my integration requirements, but I do have a very high degree of diversity in my network protocols. We support, for example, AppleTalk, SNA, DECnet, TCP/IP, and others. We have a multitude of OS platforms, a multitude of DBMSs, and also development languages environments. Very, very similar to what other IS shops face. So as do my counterparts, I also need to preserve our investment in our existing technology, while at the same time move to the client-server computing model. It seems to me increasingly at every IS conference I attend, the IS execs there are talking more and more about the same thing. How do we construct systems that support client-server and peer-to-peer approaches to computing? So, given our objectives, we needed to rethink how to approach systems design by adding a technical architecture layer.
Like many fast-growing companies, over time, Apple had built an array of individual and hard-to-integrate systems. Recently, Apple's IS team developed a strategy that would gradually pull these isolated systems together. It created a structure and a set of tools that unified existing systems from the outside. The goal was to integrate data and use data more flexibly, without radically re-engineering applications. The strategy worked. It gave users improved access to corporate systems. It bought time for IS. It even freed IS from specific vendors. Soon, Apple's customers wanted to know more about this approach. In this segment, you'll see how that strategy, called Vital, offers a valuable perspective on client-server. You'll see how Vital helped Apple design a data entry system used by the company's dealers and service providers to order products from Apple, and how another application boosted the efficiency of a management reporting system for Apple's Pacific division. We'll see why client-server will mean increased flexibility and efficiency for enterprises in the 90s, and how this technology is shaping Apple's plans for the future.
You know, as any other rapidly growing company in a rapidly changing market, in fact, we had grown up over time building systems for departments, meeting specific needs, and at some point you reach a critical mass where the needs of individual departments start coming together. When that happens, what you find out is each one of those systems was developed for specific needs, not with any idea that they'd ever be integrated. So Vital came about as a way for Apple to solve its own business problem in getting our systems integrated so we could have a global set of systems to respond to the changing needs of our business. We tend to talk about Vital not as a product, but as an elegant thinking tool, as a way to think about the problem differently, as a way to get your arms wrapped around how we can get out of this constant cycle of being behind the eight ball. Vital is our vision and framework and architecture for enterprise systems built in a client-server fashion that are easy to use, that are vendor independent, and that enable you to make the best use of your investment of installed systems. In effect, it has a migration path assumed in it. Vital also prescribes putting the right data at the right location on the right platform for the right cost. Vital involves 4 types of applications. Applications that make data, which we call data capture. Applications that store and distribute data, which we call data access. Applications that distribute the data to the desktop and allow you to produce more data. We call that desktop integration, which is generally thought of as the departmental LAN server environment with personal computers and workstations attached. And ultimately, there's also the repository environment that manages the interaction between the systems that make data and the systems that distribute data. It also is a place where you store all the business rules, all of the data about code. And so Vital supports a conceptual model of those 4 types of applications implemented in a client-server fashion on an infrastructure that is highly networked and is built for distributed computing that is multi-vendor.
Apple Order is a client-server system that's used by dealers and service providers to order products from Apple. Here's how it works. At the customer's site, Apple Order sits on a client Macintosh or local server. It includes a database containing customer and order information and a catalog of Apple products and communications software. The customer fills out orders offline by selecting parts, entering quantities, and dropping the order in an outbasket file. They can also enter queries about the status of outstanding orders. The host server includes a transaction processor that is a front end to Apple's order management system. When the client connects by modem to this server, customer information is first validated. Then the client database is automatically updated as necessary to synchronize it with the database on the host. Next, the new orders are processed, and as they are accepted by the host, the client database is notified of order numbers and estimated ship dates. When all the requests have been processed, Apple Order automatically disconnects from the network.
The benefits of actually doing client server are you can do deferred processing, meaning you do not have to be attached to a mainframe or a server to capture the transactions. So when you have a client server environment, the client submits transactions or pre-validated transactions which have a very high probability of being accepted. So given that the mainframe now can be tuned for throughput of pre-validated transactions as opposed to dealing with transactions that they have to revalidate it again and again and again.
Apple Order shows how client server can help you re-engineer a business process to reduce paperwork and communicate with your suppliers and customers more efficiently.
What we're doing is we're leveraging our IS systems to provide a service to our dealers, to our resellers and service providers by providing access to our information systems and giving them that kind of level of functionality that they need to conduct their business.
Managing the inventory is much easier since I can see what I have in stock, see what I have on order, and see if something is in transit between Apple and me. By having access to the status of the products, I can tell my salespeople what's been shipped, when we should expect it. It can help them to close more sales and give a more timely delivery on the product.
With the Apple Order system now, I can definitely say that for service, we're a lot more efficient. The turnaround time on parts is a lot faster now than it was in the past, and the paperwork has been reduced tremendously.
Apple's Pacific division needed a way to give executives access to sales and inventory information stored in flat file databases.
Apple Pacific had a system that was built on old sort of 70s technologies, and actually this is very common in information systems that tend to move slowly, technology-wise. In that system is captured a lot of sales information. That's the information that managers and executives need to make decisions. A data capture environment in this system is on the VAX, running RMS files, VAX RMS files. It's a standard distribution package that we purchase. The distribution package uses the dictionary, so we were able to use that in the Vital model to move information to the data access environment.
By moving the data into Ingress on the VAX, Turpening's team was able to build the client side of the system quickly, using Apple's data access language and off-the-shelf reporting tools, including Graphical Query Language, or GQL, from Andyne Computing. The application includes standard queries that can be made with a click of the mouse, and users can easily build their own queries and format custom reports.
One reason that it was so easy for us to rapidly develop a system is that we were able to use parts of the operating system that we didn't have to build ourselves. We were able to use publish and subscribe and thereby move information between tools without building bridges or without building onto an existing tool. And also the fact that we use standards like data access language, and we have tools like TCP/IP and DECnet, All of that on the Macintosh allows us to communicate and do client-server much easier than it would be otherwise. And by avoiding development whenever possible, we were able to give those sites with small IS staffs a system that was very easy to maintain, and that was something they definitely appreciated.
Although Vital was originally created to guide Apple's own systems development, it is now available through Apple's Enterprise Systems division.
This is a case where we built an architecture for our own needs, and as our customers heard about it, they said, I like that. Let me use that as a guide.
Vital isn't something that you adopt per se, but that you adapt to your own environment. So in other words, instead of being at the mercy of a single vendor's integration products and technologies, you now get to pick and choose based on the economics of use and the business application that you're trying to create to help run your business more effectively. You get to pick and choose among a variety of these platforms, and Vital helps you create a very coherent whole out of these disparate products and technologies without having to, I think as the fellow from Stanford said, shut down one lane of the highway. You can add a third and fourth lane to a two-lane highway while traffic still flows. So that's the benefit that I see to it.
Vital is partly a synthesis of some strategies and principles that IS people are telling the computer industry they find important. So it's not only a framework that you can use to evolve your own systems, but a guide for Apple's future as well. It's helping Apple to identify new product areas and new opportunities to collaborate with others in the industry.
Vital has expanded Apple's scope of its potential business. It's expanded our scope of where we fit in and add value. And it has also told us that where we can work very closely with vendors that in the past may have been our competitors. Customers can expect Apple to play a role in departmental workstations, personal computers, notebooks, and servers. You can expect us to also provide software as services that run on these servers. On the other hand, the parameters probably point out where we're not going to play with an Apple logo on it, where we have to cooperate with other partners. Partners that have a lot of experience in transaction processing and data capture, in managing a backbone infrastructure network, multi-vendor environment, providing lots of hands-on consulting services to build these applications and write code and so forth, requires some of the bigger partners out there. It requires some of the big systems vendors, database vendors, networking vendors, and systems integrators, and we plan to partner with a group of them. So in the 90s, no one vendor can go it alone. No one vendor can solve the problem because the problems are varied, they're complex, and frankly, you have to face the reality that customers have products from many different vendors. It's in everybody's best interest to work together.
Companies in the 90s faced big changes: downsizing, mergers and acquisitions, fast growth, new markets. Many firms are fundamentally rethinking the way they do business. And many believe client-server technology delivers the flexibility to meet these challenges. Here are some important reasons why. Client-server lets you put the right amount of processing power at the right cost, at the right location. Client-server gives you many options, from quickly building front ends for host systems to developing ambitious peer-to-peer applications. With client-server technology, you can leverage your current host systems and introduce new systems at your own pace. The companies you've seen all started with a clear idea of what client-server systems would achieve today and tomorrow. Apple technology provides the connectivity and flexibility that you need to build powerful client-server systems, systems that help you adapt and compete.
We achieved much of what we wanted to do in terms of speeding up the process of order entry in for these particular types of orders. And it's been a really powerful tool. It allowed us to get to the point where we could handle these orders once or twice as opposed to 5 or 6 times. And so it's definitely paid for itself.
What you would see today if you visited our Operations Control Center is that virtually every employee who works in there loves the system, and not only loves it to use it today, but is thinking of ways in which they can improve that system in the future. They pass that on to our development group, to our IS group, and we're off and running. So we have a very dynamic, ever-growing, ever-improving system, which will keep us number one.
I doubt very much whether any platform apart from the Macintosh could have met with the recognition, met with the acclaim, met with the support of our end users. I would say to other corporations thinking about using the Macintosh, come to BP, have a look at what we've done, and then go away and think, could you do the same in your own organisation? And could you do it better using any other platform?
We hope you found this seminar helpful and informative. Thanks for joining us, and thanks too to the people and companies who allowed us to bring you their stories about client-server architectures.